Year 9, Test 1 Practice. Question 1. Fill in the missing number. 25 equals 5 to the power of 2. How did I figure that out? Here, 5 times 5 is equal to 5 squared. 5 squared is 25. Okay, 5 squared equals 25. Here, 10,000 equals bracket 10 squared close bracket to the power of. So here we're using this index law. A to the m all to the power of n equals, and it's this, a to the m times n. Okay, so here I'm going to have a guess. All right, I'm going to put 2 in. So I put 2 in here, and let's have a look what happens. That's going to be 10 to the 2 times 2. 2 times 2, which is 10 to the power of 4. And let's check that. So I had a guess. 10 to the power of 4 equals 10 times 10 times 10 times 10, which equals, guess what? It's 10,000. Okay, 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. So we're correct. It's a 2 there. All right. 1 over 9 equals 1 over 3 to the power of something, which equals 3 to the power of something. All right. 1 over 9. That's the same as 1 over 3 squared. Okay. It's the same as 1 over 3 squared. Why? Because 3 times 3 equals 3 squared, which equals 9. All right. And that's the same as 3 to the power of negative 2, because 1 over n to the m equals n to the negative m. All right. Question 2. Simplify the following using index laws. Leave your answer as a power. So we've got here 4 to the power of 3 times 4 to the power of 5. We're going to use this index law. A to the m times a to the n equals a to the m plus n. So what this is going to be is 4 to the power of 3 plus 5, which gives 4 to the power of 5, 6, 7, 8. Here, same again. It's going to be c to the power of 4 plus 7, which is 7, 8, 9, 10, 11. C to the power of 11. Here, we're going to be using this rule. N to the power of 0 is 1. Anything to the power of 0 is 1. So we get y to the power of 0 times 2. We do 0 times 2 because there's a bracket here. So we do 0 times 2, which is 0, plus z to the 0. That's just using this rule here. N to the 0 is 1, so z to the 0 is 1, plus a to the 0 is 1. Take b to the 0, take 1. So y to the 0, that's 1 as well. So we get 1 plus 1 plus 1, take 1, which equals 2. Okay, D. 4m cubed all squared divided by 64m to the power of 4. Okay, so what I'll do that just over here. Just here. So we've got 4m cubed all squared over 64m to the 4. And 4 squared. 4 squared is 16. M to the power of 3, all to the power of 2. That's 3 times 2 is 6. M to the power of 6 over 64 m to the power of 4. All right, and next step, we've got to simplify this. So we're going to use this index law. This index law here, a to the power of m divided by a to the power of n equals a to the m take n. So here we have a divide. So we're going to take them. So it's going to leave us with 16 over 64 times by m to the 6, m to the 4. That's 6 take 4, which is m to the power of 2. So here we've got 16 m squared over 64. Okay, can we simplify this fraction any further? Let's have a think about it. How many times does 16 go into 64? So I'll do that over here. How many times does 16 go into 64? Let's have a look. How many times does 16 go into 6? Can't go. How many times does 16 go into 64? So let's have a look. We've got 16. Then we got 32. Okay. Then we're going to have 48. Okay. Then we're going to have 64. So it's 4 times. So here it's going to be 1/4 m squared. Number 4. Write these numbers using scientific notation. Here we've got 400,000. So this is going to be 4 times by 10 to the power of 1, 2, 3, 4, 5. 4 times 10 to the power of 5. Okay, why? Because we had 1, 2, 3, 4, 5 jumps after the 4. This one, this number here, it's going to be 5.76 times by 10 to the power of negative, because we're now going this way. We're going this way. So it's 1, 2, 3, 4, 5, 6, 7 times by 10 to the negative 7. Okay, number 5. Simplify the following. Make sure your answer only has positive indices. Okay, so this is a tricky one. So we've got 4y to the power of negative 3 all to the power of negative 4 times 2y squared to the negative 3. Here's how I can solve it. All right. 4 to the power of negative 4. That's this. 4 to the power of negative 4. And then I've got y to the power of negative 3 times negative 4. That's going to leave me with y to the power of 12 times, and I've got 2 to the power of negative 3. So I have 2 to the power of negative 3, and then y to the power of 2 times negative 3, that's negative 6. Then 4 to the power of negative 4. That's 1 over 4 to the power of 4. Then I'm left with y to the power of 12 times 1 over 2 to the power of 3 and y to the power of negative 6. Okay, next, so on to over here. 1 over 4 to the power of 4. That's going to be 1 over 256. Okay, y to the power of 12 times 1 over 2 to the power of 3 is 8. Yep. And why? Why? Because this y to the negative 6 goes to the bottom and becomes y to the power of 6. Okay? So 1 over 256 times by 1 over 8. Let's figure that one out. 256 times 8. So what we do 8 times 6. 48. Put down the 8, carry the 4. 8 times 5 is 40 plus 4, 44. Put down the 4, carry the 4. 8 times 2 is 16 plus 4 is 20. So there's our answer. 1 over 2048. So that's y to the power of 12 and y to the power of 6. So I did 256 to get this number here. I did 256 times by 8. Then I did y to the power of 12. That's just times by 1. So that's just 1 y to the power of 12. And that's times by 1 as well. Then we've got this y to the power of 6. Now we need to simplify it a bit further. Y to the power of 12 divided by y to the power of 6. That's going to be y to the power of 12 take 6, which leaves us with y to the power of 6. So it's y to the power of 6 over 2048. So our answer is y to the power of 6 over 2048. Question 6. Fill up the blanks with appropriate numbers or words or statements. So we've got 3.82 times 10 to the negative 31 divided by 1,000. Is this true or false? Okay, so if I did, for instance, 6 divided by 1,000. Okay, 6 divided by 1,000. What that would give me is this. 6, and it goes back 1, 2, 3 spots. So the decimal point goes there. So I'm left with 0.006. Okay, so that gives me, that's the same as saying 6 times 10 to the negative 1, 2, 3. So it brings me back 3 spots. So if I divided something 10 to the negative 31, if I divided that by 1,000, that would give me this, 3.82 times 10 to the negative 30, 32, 33, 34. So it's false. Okay, so dividing makes your number less, your index less. So it's false. Is 8 to the power of 1 times 4 to the power of all to the power of 5 not equal to 5 to the 8 times 4 to the 5? True or false? So here we can times the indices. So there's a 4 to the 1 there. Even though 1's not written, there's a 4 to the 1. So we're going to have 8 to the power of 1 times 5, which is 5, times 4 to the power of 1 times 5, which is 5. And they're the same. So are they not equal? It's false. If a all to the power of 3 equals b squared, which of the following would not make this statement true? So 1 cubed is equal to 1 squared. That's true. Is 1 cubed equal to -1 squared? For this one, that seems to be false. Let's have a look at this one. Is 2 cubed is 8, 3 squared is 9. So the better answer here is C, all right? Because 2 cubed does not equal 3 squared. 2 cubed is 8, which doesn't equal 9. So our answer is C. The amount that is charged for borrowing a certain sum is called the principal. This question doesn't apply for your test. Number 7, a bacterium has mass 6.8 times 10 to the negative 13 grams. The mass of an electron is 9.1 times 10 to the negative 31 kilograms, and the mass of a proton is 1.6726 times 10 to the negative 7 kilograms. Sort out the sizes in ascending order and giving your reasons. So ascending means from smallest to biggest. Okay, smallest to biggest. So we've got 6 here. The smallest number here is this, 9.1 times 10 to the negative 31. So what that is this. We've got our 9.1 here. And this decimal is going back 31 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and so on. So there's a whole bunch of zeros here. All right. And the decimal's way over. Okay. So this is the smallest number. All right. So 9.1 times 10 to the negative 31 kilograms. Then we've got 1.6726 times 10 to the negative 27 kilograms. So for this number, this decimal point only goes back 27. So this decimal point here only goes back 27 spots. While for this one, for this number here, it goes back 31. So it's the smaller one. And we've got 6.8 times 10 to the negative 13 grams. Now, if we need to change this grams to kilograms, all right, so to go from grams to kilograms, what we're going to do is divide by 1,000. So even when we divide by 1,000, to change this number, it's going to become 6.8 times 10 to the negative 13, so negative 13, negative 14, negative 15, negative 16. Okay, it's still the bigger number because this decimal point only goes back 16 spots. Okay, so out the size and ascending order, giving your reasons. So 10 to the negative 31 is smaller than than 10 to the negative 27 and 10 to the negative 16. The mass of a bacterium is 6.8 times 10 to the negative 13. It multiplies itself 100 times every second. Find its mass after 10 seconds. All right, so we start out 6.8 times 10 to the negative 13. It multiplies itself 100 times every second. Okay, so we're going to times it. So after 1 second, it's going to be this. We're going to times it by 100. So this number, when we times the number by 100, the index here, this index goes up. So we're going to have 6.8 times by 10 to the negative 12, negative 11. So for every zero, for every one of these zeros, it goes up by 1, negative 11 there. So that's after 1 second. So after 10 seconds, it's going to be, so we're going to times by 100 again. So it's going to give me 6.8 times 10 to the negative 11. So negative 10, negative 9. And times by 100 again. So I'm going to have negative 8, negative 7. And times by 100 again. This is going to be negative 6, negative 5. Times by 100 again. It's going to be negative 4, negative 3. Times by 100. 6.8 times 10 to the negative 2, negative 1. So how many we've done? We've done 1, 2, 3, 4, 5, 6. Here's our seventh one. Now, this is going to be 6.8 times 10 to the 1. Yep. And we're going to have 6.8 times 10 to the 3, because we're timesing by 100 again. Timesing by 100. We times by 100 again. That's going to be 6.8 times 10 to the 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and here's our 10th one. 0.8 times 10 to the 7. So there's our answer, 6.8 times 10 to the 7. So it's increased. It multiplies itself 100 times every second. And we did it for 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10.